We're going to work with a lot of equations in this chemistry class. Now, if it's been a while since you've had chemistry or any kind of science, then you might be a little bit uneasy about stuff like this. And so I wanted to take a real short video just to kind of get you back in the habit of being able to manipulate equations like this to get what you need to get. Okay? The biggest equation that we're going to really focus on this first week is called the ideal gas law. PV equals nRT. PivNert, if you just want to read it like that. Right? So this is talking about an ideal gas, and we've got pressure, volume, the number of moles of gas, so essentially how much gas we have. R is some constant, and T is temperature. In a lot of the questions that you'll be asked, a lot of the homework, maybe some of the exams, you'll always be given a gas constant, but you'll be given maybe 3 more of these variables and asked to solve for the last variable that's there. So how can I rearrange this to get each of these variables on its own? Well, first, let's try to isolate P. Okay? So what if I know volume, I know moles, I know the temperature, I always know the gas constant, but what if I don't know pressure? To solve an equation like this, what I'm going to do is get that variable I want on its own, sort of one term on one side of the equal sign, and then I'm going to divide both sides by the same thing. I can always divide both sides of an equation by the same thing. It's my right as a human being, as an American. It's just something I can do whenever I want, right? So dividing both things by the same thing, here these volume terms cancel out, and now I've got P equals nRT over V. What if I wanted to solve for moles, for N? Well, in that case, I've got N in one term all by itself over here. I don't need to add or subtract anything to get this isolated. And if I want to get N by itself, I just need to divide both sides by RT. These R's cancel out, those T's cancel out, and now I've solved for N. If I'm unsure if I did it right, one way to check my work is to check the units, right? So if my units work out the way they should, then that's a good sign that I'm on the right track. So PV over RT. The units for pressure are atmospheres. Sometimes they're kilopascals or whatever, but I like to use atmospheres most of the time. My units for volume is going to be liters. My units for temperature is K, Kelvin. And my units for the gas constant, again, this is something you look up in a book. It's kind of a weird unit, doesn't have much of a physical meaning. It kind of just makes everything else work. But my units for the R is liter atmospheres divided by mole Kelvin. So now I can start to cross stuff out, right? So I've got an atmosphere here, that crosses out. I've got liters over liters. On the bottom here, I've got Kelvin times 1 over Kelvin. And so what I end up with is basically 1 over moles, which is just moles. So fantastic. Okay, so when I'm rearranging equations, if I need to kind of check myself prior to wrecking myself to make sure I'm on the right track, I can just focus on the units and making sure that all the units that cancel out, that need to cancel out, cancel out. In a lot of questions, we're given something at 2 different states, so initial and final. Maybe this is, I started with a balloon that was only half inflated and I blew more air on it to make it fully inflated. Maybe this is, I opened up a gas tank into the atmosphere. There's lots of different scenarios, okay? But we can kind of focus on what is the, I guess, environment of the ideal gas initially, and what is it at some later time or space or whatever, okay? So these little i's mean initial, these little s mean final, okay? And so both of these equations are legit, so if we want to, we can actually just put in little, whatever the line is between in a fraction. What is that line called? The divisor? I bet it has a name. I bet a middle schooler could tell me, but I do not remember. This little line, right? So PV over PV equals nRT over nRT. Again, these are equations, so I can always divide things by equal amounts on both sides, okay? So does that get us anywhere? Well, maybe it does and maybe it doesn't. Most of the time, we're going to be able to cancel some of this stuff out. Let's go back to that balloon example, right? So if I'm taking a balloon and I'm inflating it, just that's what it sounds like when I blow up a balloon. I'm a little bit out of breath. Just give me, okay, I'm good. So what changes and what doesn't change, okay? Obviously, my volume is going to change, little balloon to larger balloon. Obviously, maybe not obviously, I'm going to add air to the balloon, so the moles of gas in the balloon is also going up. But what's not changing? Well, I don't think the pressure is really changing, although it seems like it is. Both of these balloons are under atmospheric pressure, 1 atmosphere of pressure going in and coming out. And so we can really think of our pressure as being, to at least, unless we blow it up to the point where it's going to explode on us. For the most part, our pressures are going to be the same. Temperature as well. If you ever blown up a balloon like that, you don't really see a huge temperature change and that kind of thing. So we can assume that the temperature mostly remains fixed too. And we can always assume that R stays the same, right? R is a gas constant. Constant means it doesn't change. So here in this equation, now we got simplified all the way down to V initial, V final equals N initial, N final. Okay? So that's a great simplification. Do I need to memorize this particular subset of this equation? No, I don't. And maybe that's my most important thing I need to pass along here. Okay? A lot of times people can come into science thinking, oh my gosh, I have to memorize all these equations. No. Right? It's not really like that. A lot of these equations we can rearrange to serve our purposes in whatever we're doing. And so don't think of the gas laws as a bunch of little laws, right? So for instance, you'll notice I didn't start by talking about Charles' law or Boyle's law or Peralta's law or whatever else is out there, okay? I like to start here and I can back out the relationship between volume and amount. I can back out the relationship between pressure and volume if everything else stays fixed. I can back out the difference or the relationship between pressure and temperature if everything else is fixed, okay? So I've got a lot of power under this hood. So this is how to rearrange an equation. It's a fundamental thing, which doesn't mean that it's easy, but it does mean that a lot of stuff that we're going to do over the next term is going to build on this, like a foundation, like a fundament. So if we can help you with these skills, please don't be shy about saying, hey, am I doing this equation stuff right? Because even though we say plug and chug, it is sometimes not quite as easy or obvious as plug and chug. So please come to us for help with this stuff.